Here's a video that contains two problems that are the two applications we learned in the matrix chapter. When we went through matrices, a lot of what you're going to need to be able to do on a test, on a quiz, is to be able to manipulate a matrices either in your head, especially with addition and subtraction, or using your calculator to do things like multiplication, inverses, and determinant of matrices. But what I decided I'd look at on a review video is look at the applications. We had two applications. One was finding area of a triangle using a matrix and finding its determinant, and one was using a matrix to help you set up and solve a system of equations. So we're starting with this problem, which is looking at an area of a triangular pool. And so we have set this pool on a coordinate plane, and we're going to use our formula for finding area of a triangle using a determinant to help us get our area. So the first thing we're going to need to do is write down what our coordinates are. So we're going to need to count a little bit. We count over to get each vertex coordinate. So this is the point 4, 4. This is the point 1, negative 5. And then this is the point negative 5, negative 3. And if you think back to our formula, it is plus or minus, and all that plus or minus does is guarantee that we keep our answer positive in the end, because it is area, 1/2 times the determinant of the matrix that is set up by using the coordinates where the last column, in order to make it square, is a set of 1s. So this would be 4, 4, 1. So using that first 4, 4 coordinate with a 1. 1, negative 5, 1. And negative 5, negative 3, 1. It does not matter the order in which you input the vertices. The only change that could happen is some people might get an answer that's positive, some people might get an answer that's negative, but we know in the end all of our answers should be positive. So now you're going to go to your calculator and you're going to input this matrix. So to review those steps, on your calculator, your matrix button, you have to hit second and the little x to the negative 1. We're going to edit our matrix. And what you'll notice is I actually just did this one, so you see that it's already been set up and put in for you. If you want to pause this and do it on your own as well so you can practice these steps, that's fine. But you do have our matrix already set up, ready to go. We want to get away from the screen, so I'm going to quit, do second mode. The steps to find the determinant is back to the matrix menu, but we're going to do the math menu in the middle. DET is the calculator syntax for determinant. Then we have to tell it which matrix, and it will only work for a square matrix, which is what we entered. Our answer is always a number. Now you'll notice you get a negative number. That means that you're going to have to multiply by a negative to get it back to a positive. So you can just take this answer and divide it by a negative 2. Cut it in half. That means that my pool has an area of 30 square units, whatever the particular unit we're working with. In this case, just it's on a grid, so square units. So that's the first application. In order to get full credit, you need to do exactly what you see here on the screen. You need to set up your matrix, you need to find the determinant, and then make sure you give me your answer as a positive number. The second problem is going through and using a matrix to take a system of equations that you set up and then to solve that system. And so this one is a 3 by 3 matrix because we have 3 unknowns. We're going to have to write 3 equations. So we have 3 people that we're working with, and they're telling us just use the first letter of their name to represent the variable, and you can use uppercase or lowercase. So we have Hank, Laura, and Ned, and we need to write 3 equations about the ages of these 3 people. First line says that the sum of their ages is 15, which means if we take Hank plus Laura plus Ned, we get 15. First equation, and you'll usually have one equation like that that kind of sums everything up. Now we need to find 2 more equations. The next line says that Laura is 1 year younger than the sum of Hank and Ned. So if I take Hank and Ned, Laura is a year younger than that. So this is how the equation is going to look. We're going to take Hank's age and Ned's age, subtract 1. That gives us Laura's age. So it comes up with a way to write a sentence, an algebraic sentence, from the verbal sentence. And then finally, the next sentence says that Ned is 3 times as old as Hank. So if I take 3 times Hank's age, I get Ned's age. Now the problem with it currently in this form is we have to have our matrix set up in an organized fashion. So I have to decide where I want my columns to go and be consistent. So if I look at the second equation, I need the L to be back on the left side, and I need the 1 to be on the other. So this is what it would look like. We would have H plus minus L. So I want to bring the L over by subtracting. And I have to keep it in the same order. So H minus L plus N equals 1. bringing the out over by subtracting, bringing the 1 over by addition. So I'm going to get rid of this equation now because I don't want it to confuse myself. And then the middle equation, this one right here now, I need to bring the n over and recognize that I don't have any l's. So I would have 3h, no l's, minus n equals 0. Now I want to take my equations and set up a matrix, and this is the work you're going to have to show on your test. My first line, I'm using my coefficient matrix. I get 1, 1, and 1. 1h, 1l, 1n. That's coming from this equation. My second equation, I'm going to come all the way down here. My coefficients are 1, negative 1, 1. My third equation, coming down here, my coefficients are 3, 0, negative 1. I'm trying to find Hank, Laura, and Ned, so you can write just one large X, or you can write this. That will remind you the order in which you input everything. And then my constant matrix, or my answer matrix, is the 15 from that top equation, the 1, and the 0. So now when you go into your calculator, and I haven't done these yet, so I'm going to have to input it with you, you're going to enter the matrices that you see, and then use our solving by inverses to figure out our answer. So if we go to our calculator, I'm going to move the calculator over here just so I can see my matrices that I'm entering. I go to my matrix button. I want to enter edit my matrix. It's still going to be 3 by 3, but my matrix is now 1, 1, 1. My next matrix is 1, negative 1, 1. And my final matrix is 3, 0, negative 1. I always want to input my coefficient matrix as the A matrix to keep everything consistent. Then I'm going to go back to my matrix menu, and I'm going to edit matrix B. Matrix B is 3 by 1, and this is where your constants go. So 15, 1, and 0. At this point, I'm going to quit. When it's time to solve, the solving will always be the same steps, A inverse times B. So go to your calculator, pull up matrix A, hit the inverse button, times matrix B. Now when you get your answer, you don't just want to write it as a matrix, you want to write down what these numbers mean. So your first letter was H, so that first number 2 is Hank's age. So that means that Hank is 2 years old. My next number is Laura. Laura is 7 years old. And my final answer is Ned. Ned is 6 years old. So make sure in a word problem situation you don't just write the resulting matrix. Write down what the numbers in the matrix represent in terms of your word problem. So that is what you're going to see. You're going to have a few that you have to solve that are not word problems, but probably the ones that challenge students the most are the ones where you have to take the written information, come up with your own equations, set up your own matrix, and then use the calculator to help you solve.